Hello everybody, welcome into another lesson. So today we are going to do part 2 of the binomial theorem. So yesterday in part 1 we learned what the binomial theorem was, how to find a specific term of a binomial to a power or find a specific coefficient of a term of the binomial expanded. Today we're going to actually expand these binomials to their powers and get the full result. Now, in theory, yes, we should use the binomial theorem for every single term. And remember when I said that whatever power the binomial is raised to, it has one more term than the power it's raised to. So here you have a plus 3, that quantity to the third power, which means it'll have 4 terms. But are you really going to want to sit there and do the binomial theorem for all 4 terms? I don't think you are. So here is an easy way to do that. So whenever you have a binomial to any power, here's what you're going to do. Take your first term, raise it to that power. So you're going to have a to the third power, plus you're going to get your second term. Now, to get the very next term from where you are now, you're going to take that power, move it down front, and multiply it by the coefficient on the current term you're on. So the current term you're on is the first term, and the coefficient is 1 on the a cubed, right? So 3 times 1 is 3. So your coefficient so far is 3. Then you divide it by the number of term you're currently on, which is the first term. So 3 divided by 1 is 3. So what you'll do then is you'll do that and you'll lower the power of your first term by 1 and you'll raise the power of your second term by 1. So this would be 3a squared times 3 to the first. Alright, well, if you add 2 and 1, you should still get 3. So that checks out. Now we're going to go from there and get another term. So to get my third term, I'm going to bring that power of a down one more, multiply it by the coefficient on my current term. Well, 2 times 3 is 6. Divide it by the current term I'm on, which is the second term. 6 divided by 2 is 3. So I'll have 3, and then I'll lower my power of a yet again. So a to the first, then I'll raise the power of my second term, which is 3, I'll raise that to the second power. And then to get my final term, I'm going to bring down the coefficient of a to the first, multiply it by the coefficient I already have, bring down the power of a to the first, multiply it by the coefficient that I have. So 1 times 3 is 3. And then divide 3 by the current term I'm on, which is the third term. I would just get 1. It would be 1a to the 0, which would just, a to the 0 is 1. And then you'll raise the power of your second term one more time, so this would just be plus 3 to the third. So you can simplify this more. You should get a to the third plus, you have 3a squared times 3 to the first, which is just 3a squared times 3, so that'd be 9a squared. Plus now you have 3a to the first times 3 squared. Well, 3 squared is 9, times 3 is 27, so this will be plus 27a. Plus 3 to the third is going to end up being 27. So this would all simplify into a to the third plus 9a squared plus 27a plus 27 in the end. So again, take your first term, raise it to the power that you're expanding the binomial to. To get your next term, to bring that power down front, multiply it by the current coefficient, which was 1. So 3 times 1 is 3. Divide it by the current term you're on, which is the first term. So you'll get 3 for the coefficient of your next term. Then lower the power of your first term by 1, multiply it by your second term raised one more power. And then just repeat that process until you get the end result. And I got more of these. All right. I have another one here. This time we're going to do a plus 2 raised to the 4th power. So we're taking the quantity of a plus 2 to the 4th power. So what's that going to look like? Well, take your first term, your a, raise that to the 4th power, plus, to get your second term, bring that power of 4 down, multiply it by the coefficient on a to the 4th, which is 1. 4 times 1 is 1. Divide it by the first term divided by the term you're on, which is the first term. So 4 divided by 1 is 4. So you'll have 4 times your a lowered 1 degree. So that'd be 4 times a to the 3rd times your second term of the binomial raised 1 degree, which would be 2 to the 1st. Now to get your very next term, you're going to bring down that power of 3, multiply it by the coefficient of 4. So 3 times 4 is 12, then divide by the current term you're on. Well, 12 divided by 2 is 6. So you should get 6 for the coefficient on your next term. You'll lower that a 1 more degree, which would be a to the 2nd. And then you'll raise your 2 1 more degree. So this would be 6a to the 2nd times 2 to the 2nd. Plus, to get your next term, you'll take that 2 times 6, which is going to be 12, divide it by the term you're on, which is 3. Well, 12 divided by 3 is 4. So you would get 4 times a lowered 1 more degree, so 4a to the 1st, times that 2 raised 1 more degree, so that'd be 2 to the 3rd. Then to get your last term, bring down that 1 times 4, which is 4, divide by the current term you're on, which is 4. So 4 divided by 4 is 1. A to the 0 is 1. So this would literally just turn into plus 2 to the 4th. And now we can simplify this. So you would end up with a to the 4th, plus now you have 4a to the 3rd times 2 to the 1st. So that would give you 8a to the 3rd. Plus, you'll end up having, you have 6a squared times 2 squared. Well, 2 squared is 4 times 6, that's 24. So you would get 24a squared. Plus then you have 4a to the 1st times 2 cubed. 2 cubed is 8 times 4. Well, that's 32a. You'll have 32a, then 2 to the 4th is 16. So this would expand into a to the 4th plus 8a to the 3rd plus 24a squared plus 32a plus 16. All right. Let's do x minus y raised to the 5th power. So we have x minus y, that quantity is raised to the 5th power. So again, take your very first term, that x, you'll raise that to the 5th power. You'll start there. Now, to get your next term, you're going to bring down that power of 5, multiply it by the coefficient of 1, which is 5, and then divide it by the current term you're on, which is 1. So 5 divided by 1 is 5. So you'll get 5 times that first term of x lowered 1 degree, so that'd be to the 4th, times your second term of negative 1 raised 1 degree, so that'd be negative 1 to the 1st. All right, now, to get your next term from there, you're going to do, wait, why did I say 1? That should be y. That should be negative y to the 1st, excuse me. I don't know why I thought we were doing x minus 1. You would get negative y to the 1st, but still, yeah, you're negative 1, you'll get negative y to the 1st. Okay, now, to get your third term, so take that 4 times that 5, you'll get 20. Divide that 20 by the current term you're on, which is 2. 20 divided by 2 is 10. So you'll get 10 times that first term of x lowered 1 more degree, which would be to the 3rd, times your second term of negative y raised another degree, which would be to the second power, plus, then to get your fourth term, take that 3 times that 10, that'll give you 30, divide by the current term you're on, is 3, so 30 divided by 3 is 10. Now lower your first term another degree, so that'd be x to the second, times your second term of negative y raised another degree, so that would be negative y raised to the third, plus now to get your next term, you're going to take that 2 times 10, which is 20, divide by the current term you're on, which is going to be the fourth term. 20 divided by 4 is 5, so this will be 5 times your x lowered yet another degree, so 5x to the first, times your negative y raised a degree, which would be to the fourth, and then we have one more term to deal with. So take that 1 times 5, well that's 5, divide by the current term you're on, so 5 divided by 5 is 1, and then the x to the first lowered a degree is x to the 0, that's also 1, so this will literally just be plus negative y raised to the fifth power. So that's a big expansion of 6 terms. If we simplify this, of course you'll have x to the fifth for your first term. Now 5x to the fourth times negative y to the first, that would turn into minus 5x to the fourth y. Then you have positive 10x to the third times negative y squared. This would become plus 10x to the third y squared. And then 10x to the second times negative y to the third. This would become minus 10x to the second y to the third. And then you have 5x to the first, negative y to the fourth. Well, that would just become plus 5x y to the fourth, and then negative y to the fifth, that's just minus y to the fifth. So there's the entire expansion of x minus y to the fifth. You get x to the fifth minus 5x fourth y plus 10x cubed y squared minus 10x squared y cubed plus 5x y to the fourth minus y to the fifth. So yes, some of these can get rather long. All right, now let's see here. Here's a big one. We're going to take 3r plus 2s to the sixth. So we're going to expand 3r plus 2s to the sixth power, okay? So take your whole term of 3r, raise that to the sixth power. Now, to get your next term, you'll take that 6, multiply it by that coefficient of 1. You don't want to multiply it by 3 because that 3 is inside of parentheses raised to the sixth power. So that's a 1 outside of the parentheses. So multiply that 6 times that 1 outside the parentheses, which is 6. Then divide by the term you're on, which is the first term. So 6 divided by 1 is 6. So you'll get 6 times the quantity of 3r, lowered 1 degree, so that'd be to the fifth, times your second term of 2s raised a degree, which would be to the first. Now, to get your very next term, you're going to take that 5 times that coefficient of 6, which is 30, divide by the current term number you're on. 30 divided by 2 is 15. So you'll end up getting 15 times 3r to the fourth times 2s to the second power, plus I think we got room for one more. Okay. Now take that 4 times that 15, which is 60, divide by the term you're on. 60 divided by 3 is 20. So this would be 20 times 3r to the third times 2s to the third, plus, yeah, I'm running out of room, but this is a very big problem. Now take that 3 times that 20, that gives you 60. Divide by the term you're on, which is 4. 60 divided by 4 is 15. So this will be plus 15 times 3r to the second power times 2s to the fourth power. Now to get your next term, take that 2 times 15, which is 30. So let's see, 1, 2, 3, 4, 5. So take 30 divided by 5, you'll get 6. So your next coefficient will be 6 times the quantity of 3r raised to the first power times that 2s raised to the fifth power. And then we have one more term. So take that 1 times 6, you'll get 6. Divide by the term you're on, which is 6. So 6 divided by 6 is 1. 3r raised to the 0 is also 1. So this will just be plus the quantity of 2s raised to the sixth power. So let's go through and simplify this bad boy. So 3r to the sixth, we need to find that. Alright, so let's go ahead and find this bad boy. Whatever 3 to the sixth is. No, not 36. I need 3 to the sixth. That's going to be 729. So this will turn into 729 r to the sixth plus 6 times... Alright, we need to figure out 3 to the fifth, which is 243. So this will be 6 times 243 r to the fifth times 2s, because 2s is to the first, plus, now we need to take 3 to the fourth, which I know is 81, so that would be plus 15 times 81 r to the fourth, times 2s squared, so that would be times 4s squared, plus we'll have, alright, so 20 times that 3r cubed, 3r to the third, that'd be 27r to the third, times 2s to the third, so that would be times 8s to the third, plus, alright, so 15 times 3r squared, that'd be 9r squared, times 2s to the fourth, that would end up being 16s to the fourth, plus 6 times 3r to the first, which is just 3r, times 2s to the fifth, so that would be 32s to the fifth, plus your last term, that 2s to the sixth, that's going to end up being 64s to the sixth. Which, let's simplify this one more time. You'll end up still with 729 r to the sixth, plus, now we got to take all those coefficients and multiply them. So let's see, 6 times 243 times 2 gives you 2,916 r to the fifth s plus, alright, now we got to take 15 times 81 times 4, so 4,860 r to the fourth s squared plus, alright, now let's go ahead and take 20 times 27 times 8, 4,320 r to the third s to the third plus, now let's take 15 times 9 times 16, that'd be 2,160 r squared s to the fourth plus, alright, so let's see, 6 times 3 times 32, that's 576 r s to the 5th plus 64 s to the 6th. So this is the entire expansion of this binomial raised to the 6th power. So the expansion of 3r plus 2s, the quantity to the 6th power, ends up being 729 r to the 6th plus 2,916 r to the 5th s plus 4,860 r to the 4th s squared plus 4,320 r to the 3rd s to the 3rd plus 2,160 r squared s to the 4th plus 576 r s to the 5th plus 64 s to the 6th. So I bet you're glad we're not doing the binomial theorem for every single term, for all 7 of these terms. That would become quite a bit tedious. Alright, now, when doing this application of the binomial theorem, we can also apply this to complex numbers, too. We can expand complex numbers and simplify them as well, applying the same properties that we did with binomials. So let me show you here. Alright, so let's say, for example, you have the complex number 1 plus I raised to the 4th power. So this is a complex number, right? 1 plus I raised to the 4th power. Well, take your first term of 1 to the 4th power. So you'll have 1 to the 4th, all right, plus, now take that 4 times that coefficient of 1 on the 1. So 4 times 1 is 4. Divide by the current term you're on, which is 1. You'll get 4 times that 1 down to the 3rd power, but you'll raise your I to the 1st power. Now to get your next term, take that 3 times 4, which is 12, divide that by the term you're on, which is 2. 12 divided by 2 is 6. So this will be 6 times that 1 to the 2nd times I to the 2nd power, plus, now we'll get your next term, 2 times 6 is 12, divide by 3, you'll get 4, since we were on the 3rd term. So you get 4 times 1 to the 1st times I to the 3rd. And then for your last term, take 1 times 4, which is 4, divide by the term you're on, which is 4. 4 divided by 4 is 1. 1 to the 0 is 1, so this would just be plus I to the 4th. So let's go ahead and start simplifying this. So what's 1 to the 4th? Well, that's just 1. Plus now we have 4 times 1 to the 3rd, which is 4, times I to the 1st. This would just be plus 4I. Now 6 times 1 squared is 6 times I squared. This would be plus 6I squared. Plus now we have 4 times 1 to the 1st, which is 4 times I to the 3rd. This would be plus 4I to the 3rd. Then we have plus I to the 4th. Well, we know this is going to simplify further because we have 1 plus 4I. But what is I squared? That's negative 1, right? So this would be plus 6 times negative 1. Plus we have 4I to the 3rd. What's I to the 3rd? Well, that's negative I. So this would be plus 4 times negative I. Plus I to the 4th, which is just plus 1. So we simplify this further, you would get 1 plus 4I minus 6 minus 4I plus 1. Well, you notice here, so 1 minus 6 is negative 5, plus 1 is negative 4, and then 4I minus 4I is 0. So this actually simplifies into a real number of negative 4. So pretty cool, you can do that. Now, when we get into pre-calculus, there's another method for dealing with these called de Moivre's theorem, which involves trigonometry to deal with it. But we're not going to do that in this course. That'll be in the next course in pre-calc. But For now, we're going to use the binomial theorem to simplify these. So I got 3 more examples of simplifying complex expressions that are expanded to powers. Okay, now let's say we have 4 minus I. We're going to raise that to the 5th power. So we're going to take 4 minus I, raise that to the 5th power. So take your first term in this case, which is 4, raise that to the 5th power, plus, okay, now, we got that 5 times that coefficient of 1 outside the parentheses. 5 times 1 is 5. Divide by the current term you're on, which is 1. Well, 5 divided by 1 is 5. So that'll be 5 times 4 to the 4th times your negative I raised to the 1st, plus we're going to take that 4 times that 5, which is 20, divide by the current term you're on, which is 2. So 20 divided by 2 is 10. So that'll be 10 times your 4 raised to the 3rd times your negative I raised to the 2nd. And then you'll end up having here, so your next term, so take 3 times 10, that's 30, divide by 3, for the term you're on, you get another 10, so that'd be 10 times 4 squared times negative I to the 3rd, plus, now let's see, take 2 times 10, that's 20, divide by the current term you're on, which is 4. 20 divided by 4 is 5. So that'd be 5 times that 4 to the 1st power times negative I to the 4th power. And then last but not least, take that 1 times 5, which is 5, divide by the current term you're on, which is 5. So 5 divided by 5 is 1. 4 to the 0 is 1. So you'll just get negative I raised to the 5th power. Now we're ready to start simplifying this. So let's find what the heck 4 to the 5th is. That's going to be 1024. So we have 1024 plus, now we have 5 times 4 to the 4th, which let's figure out what the heck 4 to the 4th is. That's going to be 256 times negative I to the 1st. Well, that's just negative I. Plus now you have 10 times 4 to the 3rd, which we know to be 64, times negative I to the 2nd. That would turn into positive I to the 2nd. So we'll have times I to the 2nd. Plus you have 10 times that 4 squared, which is 16, times your negative I to the 3rd. Plus you have 5 times 4 to the 1st, so that's 20, times negative I to the 4th. That would just turn into 20I to the 4th. Plus that negative I to the 5th, well, that would turn into minus I to the 5th. And we can simplify this further. So you'll still have 1024. Now, let's figure out 256 times 5. And then you have times a negative 1, that'd be minus 1280i. Now you have 10 times 64, which is going to be 640, but what's I squared? I squared is negative 1, so you would actually have this minus 640. Now, we have 10 times 16, which is 160. Then we have a negative I to the 3rd. Well, in general, what is I to the third? That's negative I, right? If we negate negative I, you get positive I. So this would be plus 160I. Now you have plus 20 times I to the fourth. Well, what's I to the fourth? I to the fourth is simply 1. It's positive 1. So this would just be plus 20 minus I to the fifth. Well, I to the fifth, remember, I runs in cycles of 4, so this would be the same as just minus I. Now we can simplify this. So let's get this in standard form. So we have 1024 minus 640 plus 20. That would give you 364. Now let's deal with the I terms. So let's see, negative 1280 plus 160 minus 1. So that would give you minus 1121I. So the quantity of 4 minus I raised to the fifth power is 364 minus 1121I. That's the complex number this would simplify into. I got 2 more, then we're done. Alright, so we have 2 minus 3I being raised to the sixth power. So we have 2 minus 3I raised to the sixth power. Well, take your 2 to the sixth power. Now to get your next term, you'll take 6 times that coefficient outside the parentheses of 1. 6 times 1 is 6, divide by the current term you're on, which is 1. So 6 divided by 1 is 6. So you'll get 6 times that 2 raised to the fifth power times your next term of negative 3I raised to the first power. Now let's do the next term. So 5 times 6 is 30. Divide 30 by the term you're on, which is 2. So 30 divided by 2 is 15. So this will be plus 15 times 2 to the fourth times negative 3I raised to the second, plus, now let's take 4 times 15 is what? That's 60. Divide by the current term you're on, which is 3. 60 divided by 3 is 20. So that would be 20 times your 2 raised to the third times your next term of negative 3I raised to the third power. Now let's get the next term. 3 times 20 is 60. Divide by the term you're on, which is 4. 60 divided by 4 is 15. So that would be 15 times 2 raised to the second power times negative 3I raised to the fourth power, plus, let's take 2 times 15, which is 30. Divide by the current term you're on, which is 5. So 30 divided by 5 is 6. So you have 6 times 2 to the first times that negative 3I to the fifth. Then we got one more term to consider. Now take that 1 times 6. Well, that's 6. Divide by the current term you're on, which is 6. Well, 6 divided by 6 is 1. Times 2 to the 0 is 1, so you'll just have plus negative 3I raised to the sixth power. Okay, now let's simplify this more. So 2 to the sixth is just 64. Now we're going to have 6. Now what is 2 to the fifth? That's 32, so you have 6 times 32 times negative 3I to the first. Well, that'll be times negative 3I. Plus, you'll have 15 times 2 to the fourth. Well, 2 to the fourth is 16. Times that negative 3I squared. Well, that'll be times positive 9I squared. plus you're going to have 20 times 2 to the third, so that'll be 20 times 8 times that negative 3i to the third, that'd be times negative 27i to the third, plus you'll have 15 times 2 to the fourth, so that's 15 times 4, times negative 3i raised to the fourth, that'd be times positive 81i to the fourth. Plus now you have 6 times 2 to the first, well that's just 12, times negative 3i raised to the fifth, that'll be times negative 243i to the fifth, plus one more term. We have that negative 3i to the sixth. So what's 3 to the sixth? So that's going to be plus 729i to the sixth. All right, so there's that thing. Now, we still have 64. Now let's take 6 times 32 times negative 3. So 6 times 32 is 192 times negative 3. That would give you minus 576i. All right, 15 times 16 times 9. That's 240 times 9 is 2,160. 2,160i squared. Now we got to take 20 times 8 times negative 27. So 20 times 8 is 160 times negative 27. That gives you minus 4,320 I to the third. Plus now we have to take 15 times 4 times 81. So 15 times 4 is 60 times 81. That's 4,860 I to the fourth. Now we got to take 12 times negative 243. That's minus 2,916 I to the fifth, plus 729 I to the sixth. Well, before we really break down the i's, let's deal with those i's that are greater than 4. Remember that i's are cyclic. So if it's greater than 4, for the power of I, subtract 4 from it and see if you have any remainder. So, or divide by 4. So 5 divided by 4, well that's 1 with a remainder of 1. So that's going to behave like I to the first, right? So this would turn into 64 minus 576i plus 2,160i squared minus 4,320i to the third plus 4,860i to the fourth. So we've determined I to the fifth behaves as I to the first, so this will be minus 2,916i. Now we got to figure out I to the sixth. Divide 6 by 4, you get 1, right? But with a remainder of 2. So this will behave as I squared. So this will be plus 729i squared. So sometimes it pays to simplify those i's if they're greater than power of 4. Now we can collect like terms. So you'll end up with 64. Now you'll have minus 576i minus 2916i. So we can collect those terms and simplify. So minus 576 minus 2916, that's minus 3,492i. Now we have 2,160i squared plus 729i squared. Those will simplify together. That would give you 2,889i squared, the positive of that, positive 2,889i squared, minus 4,320i to the third, plus 4,860i to the fourth. So it already looks a little bit better, right? Well, now it's time to simplify these i's even more. So we have 64 minus 3,492i. Now what is I to the second? That's negative 1, right? So this will just turn into minus 2,889. Now what's I to the third? That's negative I, so you take that negative times the negative on 4,320. This would be plus 4,320i. Then what's I to the fourth? That's positive 1, so that would just be plus 4,860. So let's now go ahead and simplify this into a complex number in standard form. So 64 minus 2,889 plus 4,860, that would give you 2,035 so far to start. And then we need to deal with the I terms. So we have negative 3,492 plus 4,320. So that would give you plus 828i. So that complex number to the sixth power in standard form is going to be 2,035 plus 828i. So yes, these can get very messy. Now, when we get to pre-calc and do de Moivre's theorem, I know it sounds intimidating when I'm talking about using trigonometry for it, but it's actually sometimes nicer to do it that way. Especially because we'll have some examples that are to the 20th power, or even more. And you're not going to want to use the binomial theorem to expand something to the 20th power. We see when we get into 6 and 7 powers, it's quite a bit. Imagine the 20th. Last example. We have 5 plus the square root of negative 9 raised to the third power. So we have 5 plus the square root of negative 9 to the third power. Well, what's that square root of negative 9? That's just 3i, isn't it? So this is the same as 5 plus 3i raised to the third power. Alright, now we got it in a better form we can work with. So let's go ahead and do this expansion here. So take your 5, raise that to the third power. Now take 3 times the coefficient outside the parentheses of 1. Well, 3 times 1 is 3. Divide by the current term you're on of 1. 3 divided by 1 is 3. So this will be plus 3 times that 5 raised to the second power times your 3i raised to the first. Alright, now take 2 times 3, which is 6, divide that by the term you're on, which is 2. 6 divided by 2 is 3. So this will be plus 3 times 5 to the first times 3i raised to the second. Now take that 1 times 3, that's 3, divide by the term you're on, which is 3. 3 divided by 3 is 1. 1 times 5 to the 0 is also 1, so this would just be plus the quantity of 3i raised to the third power. So let's simplify this. 5 to the third is 125. Plus now we have 3 times 5 squared, okay? So what is 5 squared? That's 25. Times 3 is 75. Times 3 is 225, so that would be plus 225i. Now 3 times 5 is going to be 15 times 3i squared, which would be 9i squared. Yeah, why don't we do that? Plus 15 times 9i squared plus that 3i to the third, that'd be plus 27i to the third. Alright, so this turns into 125 plus 225i. Now 15 times 9, that's 135, so that'd be plus 135i squared plus 27i to the third. Alright, well now we can simplify the i's. So we still have 125 plus 225i, but what is I to the second? That's negative 1, right? So this would just turn into minus 135. Now what's I to the third? That just turns into negative I, so this would be minus 27i. So let's go ahead and write this in standard form. 125 minus 135, that's negative 10. Then 225 minus 27, that would be plus 198i. So in standard form, 5 plus 3i raised to the third power turns into negative 10 plus 198i. So that's it for this lesson. That's actually it for the unit. So a lot of you have seen that the course I'm currently teaching is Algebra 2 Trig, and you're probably wondering, where is the trig? Well, wonder no more, because come next lesson, we start the last 2 units of the course, which are all trigonometry. So the very next lesson is going to be about right triangle trigonometry. It'll be kind of a refresher of a little bit of geometry with what we learned in that course, and plus we'll introduce 3 new functions. So I hope everyone has a great day. Take care.